could jealousy lead to an invention, and why would anyone be jealous of a frog in the first place? Well, I'll tell you, and along the way, I'll talk about academic dishonesty, tingly metals, reanimating corpses, scientific rivalries, and Napoleonic politics. I'll also show you how to light up an LED light bulbs with pennies and vinegar, and how to make oxygen and hydrogen out of water. Ready? Let's go.
Electricity, 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 electricity.
In 1791, an Italian anatomy professor named Luigi Galvani accidentally discovered that a dead frog leg could jump if it was touched with a probe that was electrified with a static electricity machine. He then found that the leg could also move if it was touched with two different metals, without any static or atmospheric electricity in sight. In other words, the two metals with the frog somehow created electricity. Galvani correctly decided that electricity was connected to life itself. Not unexpectedly, this paper took the world by storm. One person who was particularly interested in this paper was Italy's leading expert in electricity, a man named Alessandro Volta. Volta was a loud, boisterous man, a world traveler who spoke many languages and was known by contemporaries as, quote, a genius who swore and cackled over his experiments, guzzled and disputed over his dinner, electrified the ladies, and understood more of electricity than anyone else in Europe. Volta first came to fame by basically stealing another person's invention, an object that he called the electrophorus. In the following years, Volta made several discoveries that are not attributed to other people, like discovering methane, but most of his fame came from the electrophorus and from his oversized persona. Volta recreated Galvani's experiments and found it unbelievable and miraculous. Volta then got a live frog to jump with two different metals attached to each other and to the frog's leg and back. Volta decided that Galvani wasn't reanimating the frog, as even a live frog would move with dissimilar metals. He decided that the electricity came from the different metals, and the frog was merely responding to the electricity produced by the metals, just as it jumped from the electricity from machines and from lightning clouds. Soon it became a big debate. Was the frog jumping because it had once been alive, or was it jumping because the two different metals made electricity? Soon all of Europe split between the Voltists and the Galvanists. By the way, both sides were partially correct and partially incorrect. Galvani was correct that all living things use and produce electricity to make their muscles move and their nerves transmit signals, which is why if you artificially add electricity, even a dead animal will react. Volta was correct in that the two metals were creating electricity, which had nothing to do with the frog previously being alive. The big thing that Volta missed was the acid in the frog's leg that reacted differently to different metals. In other words, he didn't realize this was a chemical reaction and needed a chemical, an acid or a base, in order to work. Galvani was not really a good debater for the Galvanists, as in 1797 he lost his job and was restricted from publicly speaking due to his objection to Napoleon taking over Italy. Depressed and impoverished, he died the next year from unknown causes. One of the biggest supporters of the Galvanist theory was Galvani's nephew, Giovanni Aldini. Aldini, despite being a professor of physics, was much more of an entertainer than a scientist. For example, he liked to do public demonstrations, twitching the eyes or mouth of a cow's head, and even a human head of a decapitated criminal. This, for obvious reasons, gained the public's attention, and soon Galvanists throughout Europe were entertaining crowds with these gruesome shows. Years later, a young woman had a scary dream about Galvanists and wrote it up as a horror story called Frankenstein. However, despite their public appeal, these dramatic displays did not help much in academia. Volta had won a prestigious British award for explaining Galvani's experiments. However, Volta was unhappy. He didn't want awards for explaining other people's work. He wanted an award just for himself. And he needed a decisive experiment. But he was in a bit of a quandary. The only sensitive equipment to study electricity was a frog leg. He needed to make something very powerful with only inorganic materials. The first thing Volta did was to determine which metals worked the best on the poor frog. He found that silver and zinc seemed to work the best. If he put a piece of silver and zinc in his mouth on his tongue, he could feel a slight tingle. However, he put them together with wires connected to his tongue, he felt nothing. He started to wonder if the metals had to be wet. Therefore, he put a piece of silver and a piece of zinc in a cup of water. Suddenly, there was enough voltage to be noticeable on his tongue. He then added cups of water in a row and got a stronger tingle. Volta then turned the experiment on its side. He put wet, thin cardboard between a pair of silver and zinc discs and then stacked them together to get a pile. In this way, he got a relatively strong tingle, and you could get more tingling by just adding more discs and by using salt water instead of plain water in the cardboard. Here was a non-organic object that would create continual electricity with no rubbing required. In fact, Volta had just invented the battery. He published it in 1800 to tremendous acclaim. Of course, he didn't actually call it a battery. A battery was a term already in use for a set of Leyden jars, the most powerful electrical device available at the time. Now, Leyden jars stored and gave electricity in a jolt, and the battery gives a continuous flow of electricity, so they are very different. However, as Volta was trying to pump up his accomplishment, he would often refer to his device as resembling an electric battery, so you can see how the name got co-opted. Volta's victory was complete. Napoleon was quite impressed with the device and made Volta account for his accomplishments. The potential of a battery is measured in volts named after him, and often referred to as voltage, also in his honor. Volta won many awards and retired a wealthy man, never to do anything else worthy of publishing. Interestingly, in his famous paper of 1800, he still found the time to insult his old rival Galvani, who had died 2 years earlier, by writing that his research was initiated because, quote, I found myself obliged to combat the pretended animal electricity of Galvani. How did Volta's pile of metal and salt water compare to a modern battery? Well, to answer that, I need to talk about two things: voltage and maximum current. Voltage is like the power in a water pump that adds water pressure to your pipes. It is there even when no water is flowing. Most disposable batteries have 1.5 volts of potential. Just 3 pieces of silver and zinc, or copper and zinc with salt water, will produce that much voltage. And a typical pile that Volta used would produce 5, 10, and even 20 volts. You can actually make your own pile quite easily with copper pennies, zinc washers, and paper soaked in vinegar. Just like Volta, you can pile up the zinc, vinegar-soaked paper, and pennies to make a homemade battery. This pile of just 10 pennies creates an astonishing 8 volts of potential. So can I power my cell phone with a bunch of pennies? Unfortunately not. It has to do with something called current. Current is like the amount of water flow you get from the pipes. For a typical AA battery, it's around 200 milliamps of current. For the battery in your cell phone, it's around 1,000 milliamps. For a typical voltaic pile, the most it can produce is around 1 milliamp of current. However, this is enough to light up a little LED light bulb. Pretty magical, huh? So what did people do with Volta's battery before the invention of the LED light bulb? Well, they could make their tongue tingle, and they could animate dead animals and people. But the most useful thing they did with batteries in the early 1800s has to do with chemistry. See, in the same week Volta published his work, a pair of English friends accidentally put leads from a battery into a container of water. Soon the leads started to make bubbles. One probe would get bubbles of hydrogen, and one probe would get bubbles of oxygen. Plus, you had about twice as much hydrogen as oxygen. They had proven that water was made of H2O. This experiment inspired a young and handsome chemist named Humphrey Davy. to make the world's strongest and largest battery with over 2,000 plates of copper and zinc in an acid bath. From 1807 to 1808, Davy managed to electrically discover 8 new elements and increase the total number of known elements by 20%. Humphrey Davy's story is a story of how good looks, dramatic demonstration, and prolific drug use made him a scientific superstar. And that wild story is next time on The Secret History of Electricity.
Electricity, 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 electricity.
Thanks for watching my video. Please remember to give it a nice thumbs up. Also in the comments I included how to make your own voltaic pile, as well as how to get hydrogen and oxygen out of water. Both are very simple experiments to do. Also, if you're interested in learning more about Galvani and his frog, check out my video on Luigi Galvani made a dead frog jump. If you're interested in how a battery works, check out my video, How a Battery Works, a fun and simple explanation for adults. And make sure to check out that video about Humphrey Davy, who's a very interesting person in his own right, and he also ended up hiring Michael Faraday, who really changed the world of electricity. Either way, join my YouTube page, Kathy Loves Physics, my Facebook page, Kathy Loves Physics, or check out my webpage, www.kathylovesphysics.com. Okay, have a nice day.